Good day, my name is Richard and a warm welcome to Tutoring with Richard, where we cover the South African school syllabus and related topics. If you would like to help grow this channel, consider supporting me on PayPal, Patreon or Buy Me a Coffee. Links in the description box below. Today we're going to cover strength of materials in 6. The topic of this tutorial is compound cylinders. The formulas used are included in the video and the questions also posted in the description box below. We have been asked to issue a cautionary note. When doing these questions, please use the method I'm going to show you, as this is the method that is marked correct. Using your own method to answer questions could cost you marks even though your method and answer might be right. See the cautionary note at the beginning of the video. On a side note, watch until the end of the video. If you watch only the first 5 minutes, you will not gain a full understanding of what you need to do. There is no quick fix in strength of materials. It takes persistence, discipline and repetition. You have to use these steps in order to succeed. Let's get straight into it. Now we have two hollow cylinders of the same material are shrunk together to form a compound cylinder. The intermediate pressure between the two cylinders at the common diameter is 20 megapascals when shrunk together. The inner diameter of the inner cylinder is 100 millimeters and the outer diameter is 180 millimeters. The outer diameter of the outer cylinder is 280 millimeters. Now we have to calculate the hoop and radial stresses in the compound cylinder after shrinkage. So, what we are looking at is a graph that looks like this. We're looking at a graph that looks like this. So, here's our zero line. It goes like that, like this, and up towards a point, and down towards zero. So, on the inner, there's only compression. There's only common pressure of 20 megapascals at the 180. There is zero compression here. This is the shrinkage graph. This is for shrinkage. This is 100 and that's 280. Okay, so we follow our formulas. We've got radial stress. So we're going to do the inner cylinder, then the outer cylinder. So the inner cylinder works like this, but it's all the same. So R at inner equals A plus B over 0,1 squared, which equals 0. So A equals minus 100B. So the next thing to do is we have A equals minus 100B. So our next step is our radial stress at our common, which is 20 times 10 to the 6 equals A plus B over 0,18 squared. So, now what we have here, now we put all our formulas together. 20 times 10 to the 6 minus 100B plus 30,86B. So B will be equal to negative 0,289 times 10 to the 6. B, negative equals negative 0,289 times 10 to the 6. And now A is equal to 28,9 times 10 to the 6. 28,9 times 10 to the 6. Now, what we need to do. Now our radial stress, for two of them we have. Now we just need radial stress for the outer, of the outer diameter. No, all we need is the hoop stress now. The hoop stress of the inner is equal to 28,9 times 10 to the 6 minus 0,289 times 10 to the 6 all over 0,1 squared. And that equals HI, and that equals 57,8 times 10 to the 6 pascals. Now we're going to do the C part. Now we're going to do C. So that's 18 squared. So H, now that is 37,82 megapascals. Now we're going to have to work out a different set, because we're going to work out this and we're going to work out that. So with both of them. Now what we're going to do is work out the next set. So the next set is the 180 and 280 now. We're going to work out the outer, radial and hoop. So radial of C is equals 30,86. Right, now we're going to do 280. So radial of the outer equals A plus B over 0,28 squared, and that equals minus 12,7B. So 20 times 10 to the 6 equals 13,86, 12,7B. Okay, and our answer from this sum for B is 1,105 times 10 to the 6. So B equals 1,105 times 10 to the 6. Now we're going to work out A. A is, as we worked out over here, so A equals negative 14,1 times 10 to the 6. negative 14,1 times 10 to the 6. Now we've got our radial and hoop. So what we have now is we've got all our radial stresses. So with that, we're going to do hoop stress. And our hoop stress for the common is equal to negative 14,1 times 10 to the 6 minus 1,105 times 10 to the 6 all over 0,18 squared. So our answer is negative 48,21 megapascals. H common, negative 48,21 megapascals. The next one, H at outer, negative 14,1 times 10 to the 6 minus 1,105 times 10 to the 6, 0,28 squared. So this one equals negative 28,2 megapascals. So hoop stress at outer is negative 28,2 megapascals. Okay, next step. What we're going to do is do the stress distribution graph. And how stress works is like this. Goes up and all the way through. It goes all the way through. So, the next thing we do is internal pressure. So the internal pressure is given by the question. The hoop and radial stresses and the compound cylinder due to internal pressure of 120 megapascals. Okay, so this is 100, that's 180, and that's 280. So, next step is going to be basically what we've done before. Our radial on our radial on our outer. The radial on our outer, so because that's 0. So A plus B over 0,28 squared. A equals minus 12,755B. A equals negative 12,755B. Now B is going to be R, that's inner. This will be for the 100. 120 times 10 to the 6 equals A plus B all over 0,1 squared. 0,1 squared is minus 100b. Plus 100b, sorry. Now we put a in the middle, and we got minus 12,755 equals 120 times 10 to the 6. And that's B. So what we are left with is B equals 1,375 times 10 to the 6. A equals minus 17,544 times 10 to the 6. Right. So what we are looking for is hoop stress in all three. Oh yes, and radial stress and right in the middle. And so radial, common, radial and the common. So radial common is equal to negative 17,544 plus 1,375 times 10 to the 6 times 10 to the 6 all over 0,18 squared. And then our answer is 24,89 megapascals. 24,89 megapascals. Next step is now we're going to do the 3 hoop stresses. So hoop stress on the inner will be equal to negative 17,544 times 10 to the 6 and minus 1,375 times 10 to the 6 all over 0,1 squared. H for the inner, and that gets me to negative 155 megapascals. Now we do the same. One comma 8 squared. H common. Now H common is minus 59,98 mega, and H outer, which is 28, is minus 35,08 mega. Minus 35,08 megapascals. Alright, now we have all our values. Now we can get our resultants. So once we do that, we will have finished. So, our radial for the all of it is DC equals DI, 100 equals 0 plus 120 equals 120. DC is 180 equals 20 plus 24,89. We got that from here. Equals 44,89. Now, you must remember this is all in megapascals. The outer 280 is equal to 0 plus 0. That's 0 megapascals. So now the hoop. The hoop stress for the resultants, you've got to do your first your hoop for your inner cylinder, then the hoop for the outer. Hoop for inner, is HN equals 100 equals 57,8 minus 155 equals minus 97,2. Hoop stress for 180, hoop stress at C, 180 equals 37,82 minus 59,98 equals minus 22,16. Now we do hoop outer. Now we do hoop outer. So DC 180 equals minus 48,21 minus 59,98. This is minus, so it's plus a minus. So this is all plussed. So 108,19. The outer, that's 280 equals minus 28,2 minus 35,08 equals minus 63,28. Now all the minuses that I've just shown you, all of the minuses are tensile stress. So anything that's not a minus, any hoop stress or anything else that's not a minus is a compressive. So all of these are tensile. If you found this tutorial helpful, please give it a like and subscribe. It helps to grow the channel. Positive feedback is most welcome. If you would like to help grow this channel, consider supporting me on PayPal, Patreon, or Buy Me a Coffee. Links in the description box below. Be at peace, be kind to each other, and remember, passing well is achievable. Have a great day. Looking forward to seeing you in the next video.